All right, this is bringing us near the end of our factoring lessons, if you will, the video lessons. Of course, if you ever have questions on homework, I can make you a quick little video explaining things. But we're going to put everything together in this video and talk about a strategy for factoring polynomials. You see, because you're going to get worksheets now where all these different types of problems are mixed, and you're going to need to be able to figure out what type of factoring you need to do. All right, so strategy for factoring polynomials. We always, the rule is first look for a GCF, because if there is a greatest common factor, that helps us make the polynomial a bit smaller and more easier to work with. So first, look for a GCF. Always do that first. Then, take a look at the polynomial. You're either going to have a binomial, a trinomial, a polynomial with 4 terms. Okay, so if there are only 2 terms, meaning it's a binomial, sometimes it is only a GCF problem. If it's not a GCF problem, then it could be the difference of 2 squares. It could be dots. All right, and if it's dots, well, dots is always going to factor as a plus b times a minus b. It could be the sum of cubes. And sum means add, so that's, you're going to see a plus sign there. Or it could be the difference of cubes. See, the reason you can factor sum and difference of cubes is because, think about taking the cube root of something. That something could be positive or negative. The cube root of a negative number is real, but the square root of a negative number is not real. So difference of cubes. So the cubes, we can do both. Just, again, think of the cube root. You could take the cube root of a positive number, or you could take the cube root of a negative number. But that doesn't work with squares. Okay, so we can only do one thing with squares, and then we can only factor one way with squares, and that's the difference, the dots. Sum of cubes will always look like a plus b times quantity a squared minus ab plus b squared. And the difference of cubes, remember there'll be subtraction there, so it's a subtract b times the quantity a squared add ab plus b squared. Okay, so on a test or a quiz, we would probably give you these models. You would just have to know what they represent. All right, that's what you do if there's only 2 terms. Could be a GCF, but you'd always be checking for that first anyway. Or it could be one of these, dots or the cubes. If there are 3 terms, well, if there are 3 terms, it could be a perfect square trinomial. Perfect square trinomial. And remember, your perfect square trinomials are going to factor either as a plus b quantity squared or a minus b quantity squared. However, if it is not a perfect square trinomial, then you need to use trial and error. All right, if there are 4 or more terms, try factoring by grouping. Remember, when you factor by grouping, you're looking for a GCF in each group. And then at the end, you have to take a look to make sure that the polynomial is factored completely. All right, so we've got 4 examples, and then one of the examples is a challenge example. And you will find a challenge example on a test or a quiz. Just keep that in mind. So this is something that you do need to know. All right, let's look at example A. I'm going to puzzle this, I guess, if you will, separate it off. Okay. 8a squared subtract 8. The first thing you always do is look for a GCF. Is there a GCF? And you should say, yes, there's a GCF. The GCF is 8. I'm going to factor it out. And remember, factor means divide. So I'm going to divide this term and this term by 8. And that's going to leave me with a squared subtract 1. I'm not done because a squared and 1 are both squares. This is dots. So I'm going to keep the 8 as part of the original answer, and now I'm going to factor the a squared minus 1. Well, that's going to be a plus 1 times a minus 1. I know they're both 1s because 1 is its own being. It's not prime, but the only way to get 1 is 1 times 1. Final answer. These two items have nothing in common other than 1, but you could sit there forever and a day, keep on factoring out that 1. Okay, so here at the step where we have completed it. Let's go down below it to letter B. 75x to the power of 3 subtract 12x. A good indicator that this has a GCF is if all of your terms have a variable, the same variable. And this example, it does. So we can take an x out. And if I look at 75 and 12, you should be able to see that 3 divides 75 and 3 also divides 12. So this actually starts out as a GCF problem. I take a 3x out. Now remember, factor means divide, so 75 divided by 3 is 25. X cubed divided by x is x squared. 12 divided by 3 is 4. Negative over positive is negative. X over x, the x came out. And you might think you're finished, but you know, you got to look at what's inside the grouping here. 25 is a square. So is x squared. So is 4. This is dots. So I have to break that down. The 3x stays, and now I'm going to break down my difference of two squares. Remember, that's always a plus b times a minus b. Take the square root of this, you get 5x. Take the square root of 4, you get 2. So that's 5x, and that's 2 as well. 2 and 5 are both prime. There are no other common factors that I could remove. Letter C, I've got 3 terms. This could be a trial and error. I don't know. I want to look for a GCF first. Is there a GCF? You say, yes, there's a GCF. They all have an x. This one's got 1x. This one's got 2. This one's got 3. So the most I could take out of each is 1. 3 divides all of those coefficients. So I'm going to take out a 3x again. So I'm going to divide each term by 3x. 3 over 3 is 1. X cubed over x is x squared. 30 over 3 is 10. The sign has got to be negative. Negative over positive is negative. X squared over x is 1x. 75 divided by 3 is 25. The sign is positive. And the x came out, right? X over x is 1. 25 times 1 is 25. I'm not finished. I have a trinomial. I'm looking at it and I'm thinking, all right, what two numbers multiply to 25 that when I add them give me a 10? Well, that's 5 and 5. Signs are the same, they're both minus. So that means that I have 2 of exactly the same ones, so I have to clean it up. My final answer here is 3x times the quantity x minus 5 squared. All right, if you have questions, remember these are all going to be mixed up and you're going to have to know what to do, what strategy. That's why we put this note sheet together for a strategy for you. This one here is 4 or more, and I'm going to tell you that this one factors differently. Not like any factoring we've done so far. You know, if I try to put these first two terms together, they have nothing in common. Yeah, I could put these two together, the x squared and the x, and I could pull an x out, But when I look at 49a squared and 225, they have nothing in common. So grouping 2 and 2 here is not going to work. However, it is still grouping. And notice there's no GCF. All right, so no GCF. Grouping 2 and 2 won't work. But notice what's going on here. I have an x squared here, and I have an a squared as well. This is an x, and that's a constant. So this kind of problem is ones that we're going to group as a trinomial and a monomial, and then we're going to trick the monomial. So we're going to write here. Notice there are, I'll move my paper up, 2 distinct quadratic terms. Meaning your x squared and your a squared, right? Something raised to a power of 2 is quadratic. So there's no GCF, and I'm noticing that doing 2 and 2 together is not going to work for me because there's no GCF with those groups. But I do notice that there are 2 distinct quadratic terms, an x squared and an a squared. Okay, x squared and a squared. That's going to be an indication that you're going to group a trinomial and a monomial. Group a trinomial and a monomial. All right, so I'm going to take this distinct term right here, this one, and group it off by itself. The one that's different. Okay, so I'm going to group x squared plus 30x plus 225 together as a trinomial. And then the one that is unlike those, I know 225 doesn't have an x. However, I want to make a trinomial and a monomial, and the a squared is the one that has to get bumped out by itself. And that's why I'm putting the 225 with those x terms. All right, well, then we got to trick this 49a squared. We're going to rewrite it. So let me first copy down this part. X squared plus 30x plus 225. Group it, subtract. And now I'm going to rewrite 49a squared as something raised to the power of 2. So what squared is 49? And you say 7. And what squared is a squared? And you say a. All right, so I'm just tricking and rewriting 49a squared as 7a to the second power, that product to a power. Now, this over here is a perfect square trinomial. You know, square root of x squared rather is x. Square root of 225 is 15. If I have two 15s, I'm going to get 30. So this actually is going to factor into x plus 15 quantity squared minus 7a quantity squared. And now what you should be seeing here is dots. Okay? It's a squared minus b squared. All right? So that's dots. D-O-T-S. Difference of two squares. We know the difference of squares is going to factor as, well, we'll write it here. A plus b times a minus b. So I'm going to write my parentheses a little bit wide. Excuse me. My a is a quantity x plus 15. It's plus b. My b is 7a. I could put that in parentheses. My a is quantity x plus 15 minus my b is 7a. Now, sometimes you have a little bit more work to do in here. In this case, we don't, because x and 15 and 7a can't be combined. So the only thing you really could do is just write this as x plus 15 plus 7a times x plus 15 minus 7a. And that's how that polynomial group of 4 is going to factor. It factors as a trinomial and a monomial for grouping. You trick the monomial and rewrite it into something with a squaring on the outside, and you end up getting dots. Dots always factors as a plus b times a minus b. What's my a? Well, this is my a squared. It's the whole x plus 15. So you put that there. A plus b, b is 7a, and then a minus b right here in the grouping. So if you have any questions, you know what to do. Post a comment on the homework discussion. Ask for a little video explanation. Come to a Google Meet. Ask a question in class. We're not going to be in class, so your next best thing is to come into the Google Meet for some help. All right. Have a great day and have a great upcoming holiday.